All right, math friends, we're going to continue our unit on solving rational equations. And I'm going to do another set of equations that are, quite frankly, crazy. I mean, look at them. They're nuts. And we're going to pick up from where we left off in the previous video. And I would warn you, highly warn you, if you have not watched the Solving Rational Equations 1, just don't even bother continuing from here, because it's going to be, I don't know if you can handle it. Maybe you can, I don't know, but I would suggest you watch that first one first. So a brief recap of how we handle equations with fractions. I showed in the previous video, there are two ways that we can work with equations with fractions. We can either clear the fractions by multiplying all the denominators, or we can simplify each side to have one fraction on each side of the equal sign and then cross multiply. And so we were working on those with basic stuff in the previous lesson. And so we're gonna use those skills for things that are a little bit more complicated. And then also to remember, in the previous lesson, we were talking about domain restrictions. Okay, so looking at denominators all the way across and seeing what the variable can and cannot be based on how the domain might be restricted. So we're going to jump right into to these problems because we've done all of the previous note-taking in solving rational equations 1. So like I said, if you have not yet taken notes on any of this stuff, you got to not work with this video. So there are two ways we can work with number 1. We could either clear the fractions, or we can simplify each side and then cross multiply. For this one, I think I don't know. I'll clear fractions for this. And so the way we clear fractions for this is multiply everything by the denominator. So if I look at these denominators, I have two different ones. I have 5x minus 1 and x. So I have two different denominators. So the first denominator I'm going to multiply by is 5x minus 1. So I'm going to multiply each number by 5x minus 1. And so I'll have the first number, the second number, and the third number, and all three of them are going to be multiplied by 5x minus 1. And so we'll see what kind of interesting things occur. Okay, so remember why we were clearing fractions is that, well, giant 1s cancel. And so you can see in the first number that giant 1 cancels, and that leaves us with 5x. In the second number, there is no giant 1 to cancel. So that basically stays 5x minus 1 over x. And then in the number on the other side of the equal sign, the giant 1 cancels, and that leaves us with 1. So we have attempted to clear fractions, but clearly we're not done yet, right? Because we have another fraction. So what do we do? Just like in the previous lesson, we clear fractions again. Okay, so again, we're going to multiply everything by the denominator. In this case, the denominator is x. And so we multiply everything by x. And so I'll pause right there on that second number. Notice that we are multiplying the entire numerator by x, right? The entire numerator gets multiplied by x, so be careful there. Okay, so everything gets multiplied by the denominator. And you'll see why in a second, because it's going to cancel out, right? So in our first number, it's now 5x squared. In our second number, the giant x cancels, and that leaves us with that numerator that we had, 5x minus 1. And then our third number is x. So there we have it. Okay, so there we have no more fractions. But now, since there are no more fractions, what do we do? And so we need to remember a previous lesson on solving polynomial equations. Okay, so solving polynomial equations. We've done this before. So how do we solve polynomial equations? You should be saying it with me. Starts with an S, ends in et equal to 0. Okay, so we're going to set everything equal to 0, and then we use, what do we use? That's right, starts with a Z, ends in zero product property. Okay, so we have to remember how we solve polynomial equations. We set everything equal to 0, and then we use the zero product property, which means we will be factoring and setting stuff equal to 0. Okay, so that's all refresher from solving polynomial equations. So if you are stuck here with what I'm about to do, there's an entire playlist on polynomial equations. You want to look for solving them. Anyway, so what do we do for solving polynomial equations? We set things equal to 0. I have an x here. I'm just going to subtract x from both sides. So my 5x squared stays 5x squared. If I subtract x from both sides, that means I have plus 5x minus x, or plus 4x, and then minus 1 equals 0. Okay, so I've set my polynomial equation equal to 0. And now I'm going to use the zero product property, which means we have to factor. So we got to see if we can factor this polynomial. And I'll use factor by grouping. Super quick to refresh your memory. So the first thing we do is multiply a times c. Right? Don't forget, we're multiplying a times c is negative 5. So it multiplies negative 5 but adds to positive 4. Okay, so that's the puzzle for factoring. Okay, so the puzzle for this factoring, multiply 5 times negative 1, negative 5. What multiplies negative 5 but adds positive 4? Hopefully you know it's positive 5 and negative 1. That would fit that puzzle, right? And so once we do that, we can factor by grouping. And so in our first two, the GCF is 5x. We will be left with x plus 1. In the second two, the GCF is 1, but remember, we have to factor out a negative 1. Okay, so if that sign is negative, we're going to factor out a negative 1. And then we'll be left with x plus 1. And then we have a common binomial of x plus 1. And then once we take out that common binomial, we'll have left 5x minus 1. So we have factored our polynomial. Okay, so we factored our polynomial. And now we can use the zero product property. Okay. So if what I just did, again, if what I just did was confusing, you gotta seriously stop this video and go back to watch Solving Polynomial Equations. It's a whole other video. You can find it there. But if what I just did was confusing, you're going, wait, what, Mr. Katz? I don't even want to hear the question. Stop what you're doing. Go back to the previous video. Shame on you. All right, anyway. So once we're here, we're going to use the zero product property. That means x plus 1 equals 0, or 5x minus 1 equals 0. Then we solve each equation for x. So our first solution is negative 1. Our second solution is positive 1/5. Okay? But time out. Remember from the previous video, time out. Now we got to check. And what do we check for? We check for domain restrictions. Domain restrictions. And what are domain restrictions? Any values that make denominators 0. Okay, so any values that make denominators 0 cannot occur. Okay, and it's any denominator, by the way. So it doesn't matter when the denominator occurs. The denominators can equal 0. So what we do now is we go right back to the very beginning, and we start looking for domain restrictions. So check this out. In our original equation, we have 5x minus 1 in the denominator. So basically we're saying 5x minus 1 cannot equal 0. Therefore, x cannot equal positive 1/5. That's our first domain restriction. X cannot equal positive 1/5. In the second denominator, we have x equaling 0. So we're saying that denominator cannot equal 0. So x cannot equal 0. And the third number has the same denominator. So again, x cannot equal 1/5. So we have these two restrictions. X can't be 0 and x can't be 1/5. And now we're going to look through to see if there's any other denominators anywhere. Okay, so that's the same. We've already checked that denominator. We checked that denominator. We've checked all the denominators. So we do have domain restrictions. Okay, the domain restrictions that we have found is that x cannot equal 0 and x cannot equal 1/5. Okay? Remember the end of the previous lesson. And again, if you haven't watched that previous lesson, you're probably going, what? And again, I've told you, stop, go back, watch that one. Anyway, so we have our two solutions. We found x to be negative 1 or x to be 1/5, but domain restriction x cannot be 1/5. Therefore, this is actually not a solution, what we call extraneous. Extraneous, unnecessary, not proper. So there's only one solution to this entire equation. One element in the solution set, which is x equals -1. So we have to be careful with what we're finding because we might run into an extraneous solution. So we want to be careful with that, and hopefully that helped. So we're going to move on to the next example. So remember extraneous solutions. All right. So now take a look at this. Here's number 2. So we're going to work on this next one. This gets crazy. Okay. So we got to figure out. All right. What are we going to do? How are we going to do this? Are we going to simplify it, or are we going to clear fractions? And I think for this one, I'm kind of digging clearing fractions, so I'm going to keep doing that. Because I think in the first video, all I did was simplify, but now what I'm going to do is start clearing fractions because it's more, to me, it's easier. So how are we going to clear these fractions? Well, the first thing we should do is probably, what do you think? Look at that. Look at that second number. What do you think we should do with that second number? Good answer. We should factor it. I know everybody at home or in class was saying, hey, factor that, Mr. Katz. Yeah, good call. Totally. So that's a difference of squares, which factors into conjugates. Know your vocab. So we factor that into conjugates. Now we can see what we can start multiplying. By. Okay. Now here's where I'm going to do something pretty darn cool, and I hope you agree with me. Now we're going to clear fractions. I'm going to anyway. And so I'm going to multiply things by the denominator. So it doesn't matter how. I can multiply everything first by x minus 2, and then I can multiply by x plus 2, or I just multiply everything by this denominator. If I multiply everything by the more complicated denominator, cool stuff is going to happen. So I want to multiply by the more complicated denominator first. Maybe that's a nice little note to take. Multiply the complicated denominator first. Bloop. So let's see what that would look like. Okay, so I'm going to multiply everything by x minus 2 times x plus 2. X minus 2, x plus 2, I'll multiply it there. X minus 2, x plus 2, I'll multiply it there. Remember, we're multiplying the entire numerator. And then over here, x minus 2, x plus 2. All I'm doing is clearing the fraction. Now, I know you may be thinking, holy cow, that was complicated. No, I'm telling you, it is the exact same thing as what we did for the original note from the previous video. All we're doing is the exact same thing from the original note from the previous video. We're just multiplying everything by denominators. That's all. Okay? So what? We're using parentheses. Big deal. Get over it. It's just grouping symbols. They're not going to bite. Okay? But the concept remains the same. I don't want you to look at this and say, oh my God, that's too much. Well, it is if you look at it for the very first time right now. But you have to keep in mind, the concept is simple. We're multiplying by denominators. So anyway, what's going to happen when we multiply everything by this crazy denominator? Look for our big ones. Right? So check it out. The first number, x minus 2 over x minus 2, cancels. And what are we left with? X plus 2 times 2. Now I'm going to go ahead and simplify that just to make the video move quicker. So I'm going to distribute my 2. Okay, all I've done is use the distributive property. So I canceled, and I've used the distributive property. Okay, so chillax. Now, for the second number, look what's going to happen. X minus 2, x minus 2, x plus 2, x plus 2. Right? Remember the lesson on simplifying rational expressions. And so I'm left with minus 5 plus 2x. Oh, why didn't you tell me that before? Oh, because it's a one-way video. That's why. No big deal. So it's 5 plus 2x. So remember, I am subtracting that entire thing, though. Okay, so when I'm subtracting this entire leftover numerator, I'm going to subtract the entire leftover numerator. Okay, so it's going to be a minus 2x. Fraction gone. Look at all these fractions disappearing. Isn't that cool? Now on the right-hand side of the equal sign, see if you can cancel a big 1. X plus 2 cancels. And so I'm going to simplify what I have left. X squared minus 2x. And so fraction gone. What am I left with? A polynomial equation. Okay, so I'm left with a polynomial equation. And what does that mean? Set it equal to 0, and then use the zero product property. But first, I'm going to simplify stuff. I want to simplify the left-hand side. Look at this left-hand side. This is awesome. Check it out. 2x minus 2x, gone. Donezo. 4 minus 5, negative 1. That's all I have left on the left-hand side. On the right-hand side, that is as simple as we can get it. X squared minus 2x. But remember, I'm dealing with a polynomial equation. So we have to set things equal to 0. The easiest thing to do, hopefully you see this, the easiest thing to do is to add 1 on both sides. That's going to be the easiest thing to do. So I have 0 equaling x squared minus 2x plus 1. Uh-oh, you best recognize. So hopefully you see what's going to happen. Now we're going to factor the right-hand side and then use the zero product property. So we're going to factor that right-hand side. So you can use factor by grouping. You can use the x factor method, or I'm hoping you recognize specials when they're looking you in the face. Okay, and this one's looking right at you in the face. That is x minus 1 squared. Okay, that is x minus 1 squared. So we recognize our perfect squares. So if x minus 1 squared is equal to 0, that means all we have to do is set one thing. X minus 1 equals 0. Therefore, x equals 1. Okay? But hang on. Before you go circle crazy, let's check for domain restrictions. Bum, ba-da-dum, bum, bum. Are there any values for x that we cannot have based off of denominators? Okay, so we go right back to the very beginning. So if we look at our denominators from the beginning, x minus 2 cannot equal 0. Therefore, x cannot equal 2. So far, so good. X squared minus 4 was x minus 2, x plus 2. So that means x minus 2, x plus 2 cannot equal 0. So x cannot equal 2 or negative 2. So far, so good. And then the third denominator, x plus 2 cannot equal 0, so x cannot equal negative 2. All right, so far we're saying x can't equal 2, x can't equal negative 2, and x can't equal 2 or negative 2, which is basically what we just said. Quit being so repetitive. All right, now we're going to see, are there any other denominators that are in this craziness of this problem, right? So there are no other denominators, so our domain restrictions are very basic. X can't equal 2, x can't equal negative 2, which is totally cool because we're saying x is 1. So right on. Legit, dude. So our solution set, x equals 1. Because guess what? 1 is not 2 or negative 2. Right? We knew that in kindergarten. So word. We've just solved that. We've solved that equation. Isn't that fun? Yes. Awesome stuff. So we want to get ourselves to polynomial equations. We want to look for domain restrictions. We'll be having fun. Speaking of fun, number 3. We'll end this video because we're just getting some good practice on solving these wacky equations. So if you remember what we did in number 2, the first thing to recognize, hopefully you're already recognizing that for number 3. What was the first thing we did in number 2? Hopefully you're recognizing that for number 3. And it begins with an F and ends in actor. Okay, so we're going to factor our denominators. Probably a good idea to look into doing that first. So let's look at this crazy denominator here. 2x squared minus x minus 6. I'm going to use x factor to factor this one. Why not? So I have 2x and x here. What two numbers multiply to 3 and 2? To 6. So how about 3 and 2? And if I go across the line there, I got 2x. If I go across the line here, I got 3x. That's what I want. Or excuse me, 4x. So 4x and 3x. The 4 is going to have to be negative. So that's going to be a minus 2. The 3 is going to have to be a positive. So that's going to be a plus 3. So we have now factored our denominator. So 2x plus 3, x minus 2. That's that denominator factored. This denominator is already factored. This denominator has a GCF. Don't forget, that's totally a method of factoring. So we have x minus 2. Okay? Okay. So what are we going to do? We're going to multiply everything by the denominator. We're going to clear fractions. I'm all about clearing fractions. Now, you can simplify stuff, no doubt. I mean, we spent a giant unit on that. So no doubt you can multiply stuff, but I want to clear fractions, and so I'm going to do just that. Okay, so here's my crazy equation now. I'm going to multiply everything by the denominator, the most complicated denominator first, which of course is this first denominator, because that is a crazy denominator right there. That denominator is nuts. So I multiply everything by 2x plus 3 times x minus 2. And let's see what kind of magic happens. You never know, right? Just don't be afraid of parentheses, right? You look at this stuff, I know people, oh, this is so complicated. You only think it's complicated because you're scared of parentheses. Ooh, a parenthesis, go hide, right? That crazy clown in Poltergeist is way worse than that. Anyhow, so we start looking at our numbers. Let's cancel some things out. 2x plus 3, gone. X minus 2, gone. We're left with x. No more fraction there. Sweet. Now, look at that second number. Is anything going to cancel? No. So that's pretty bizarre. So we have our minus this crazy-looking fraction. We just got to be careful. That's all. Don't lose your brain, right? Just be careful. And don't be afraid to write. Oh, no, some more pencil strokes. Big deal. Okay, so nothing cancels. There is no big 1 here, so that stays put. On the other side, though, look what's going to happen. X minus 2, but that's it. We don't cancel that x, right? So we're left with our numerator. I'm not going to distribute yet. I don't need to. That's what we have left, okay? And I know you're thinking, but Mr. Katz, we still have fractions. Yeah, so guess what? We've done this before. Then clear fractions again. Let's multiply everything by the denominator. We have a denominator of 3x. So let's multiply everything by 3x. No big deal. As long as you're using pencil strokes and you're seeing the big picture of things, there's no need to panic. So we're going to multiply everything by 3x. Okay, no need to panic. Okay, all right. Let's see what kind of magic happens. The first number becomes 3x squared. The second number cancels. And we're left with that crazy numerator. So I'm going to watch this. I know you're going to lose your marbles because you're so afraid of pencil strokes. Oh no! It's a bracket. All brackets are bigger parentheses. I don't feel like multiplying that out yet. I will in a second. So I'm just going to use a bracket, right? Don't be scared. It's no big deal. Ain't going to bite you. Okay, so the bigger parentheses. See the big picture. Just grouping it. Now on the other side of the equal sign, we have an x and an x that cancels, and so we're left with 6 times 2x plus 3. Okay? So now we have this bizarre looking, what in Yiddish, mishigas, like craziness. It's like just nuts. The first thing I'm going to do is simplify this. I now want to simplify what's inside that big bracket. And so I'm going to distribute my binomials. I'm going to use the distributive property, or what is commonly improperly referred to as foiling. Foiling involves aluminum foil. Anyway, so we have 2x squared, and then minus 4x plus 3x. Minus 4x plus 3x is minus an x, and then 3 times negative 2 is negative 6. Okay, so I have just used the distributive property in my head for those two binomials. All right? Don't be afraid. It's just I'm going step by step. Hopefully you're listening too, not just watching. I'll catch you all sleeping. So now I have my 3x squared. Careful of that minus sign. That's going to be now minus 2x squared. That's now going to be plus x and plus 6. So you have to be careful with subtraction. Subtraction is a crazy, crazy thing. And now on the right-hand side, we can distribute. So we have 12x plus 18. Okay? So yes, you can see we're going to have a polynomial equation. I know you see that. But I want to simplify stuff first before I go crazy. So 3x squared minus 2x squared. That's convenient. That works out. X squared plus x plus 6 equaling 12x plus 18. The cool thing is we're going to find out where a straight line intersects a parabola, but ignore that. All right, so now I'm going to set everything equal to 0, and then we're good. So the first thing I'm going to do is subtract 12x from both sides. I subtracted 12x. X minus 12x, negative 11x. I'm going to subtract 18. 6 minus 18 is negative 12. And now I just need to factor and use the zero product property. Okay? So I'm going to factor x squared minus 11x minus 12. That's x minus 12 times x plus 1 equaling 0. And now I have my solution set. Okay, so clearly my solution set, x will equal 12 or x will equal negative 1. Okay, but before we go crazy, what are the domain restrictions? So we're going to look at every fraction and see if we can look for domain restrictions. Okay, so we start at the very beginning. It's hard to see what the domain restrictions are from the original thing, which is why we factored. Okay, so if you remember we factored the first number, we see that x cannot equal negative 3 over 2. So if we set this equal to 0, x cannot equal negative 3 over 2. X cannot equal positive 2. In this denominator, x cannot equal 0. And this denominator, we've already set that x cannot equal 0 and x cannot equal 2. So our domain restrictions, we say that x cannot equal negative 3 over 2, x cannot equal positive 2, and x cannot equal 0. And that will account for all of our denominators. Okay, so we have found all of our domain restrictions. We found all of our domain restrictions. And the cool thing is, that don't affect the solution set. The solution set is still the same. X equals 12, x equals negative 1. Bam! Solving rational equations. Okay, so that's it for solving rational equations 1 and 2. The next lesson is going to be all those stereotypically horrible word problems. But that's enough for now, because if we get this, we'll be okay with word problems. Thank you for your time. Enjoy.